Alright guys, let's take a look at question number 9. Alright, so the quantity 3x squared times y to the third all raised to the third is equal to what? Alright, so this is another typical TSI question that you're going to see. And there are basically 3 rules for exponents that we need to make sure that we know. Okay, so the first rule is this, is that if my base is the same, base being the big number, if they're the same, then I can add my exponents. So this is the same thing as saying 3 plus 2. This is the same thing as saying 3 plus 2, which is 5. Okay? So if we multiply, if the bases are the same, we can add the exponents. All right? Now, I'm going to do a quick little thing just to try to drive your intuition. This makes sense because x to the third means what? Well, x to the third means x times x times x. X squared means what? X times x. Well, how many x's do you have? You have 5 of them, right? So this means what? This means just x to the 5th. Okay? So this means that you have 3 of them. This means you have 2 of them. Okay? Keep note that if I give you a number like 4, that's like 4 to the 1. So if I have 4 to the 1 times 4 squared, again, that just means I add them. So 4 to the 1 plus 2, which is 4 cubed. Okay? So this is your first rule. The second rule is basically the same rule, but if you divide. So if we see x to the 5th divided by x squared, well, what does that mean? Well, that means you, instead of adding these exponents, you subtract. X cubed. Okay? Now keep in mind again the bases have to be the same. Okay? And this means subtraction. Why does this mean subtraction? Well, again, division is just multiplying by the reciprocal. So what is x squared? X squared in the denominator, rather 1 over x squared in the denominator, is really just x to the negative 2. Okay? I point this out. I'm doing this because you may see questions on the TSI that talk about this issue. Okay, so keep in mind that 1 over x squared is the same thing as x to the negative 2. So what is this really saying? Well, this is x to the 5th times 1 over x squared, which again is just x to the 5th times x to the negative 2, which means I'm doing what with these two values? Well, because the bases are the same, we just add them. So what's x? Oops. What's x to the 5 plus negative 2? That's 5 minus 2. It's the same thing. That's x cubed. Right? Maybe another way to drive your intuition is, what does this mean? Well, this just means this is just nothing more than 5x's on top and 2x's on the bottom. So these will cancel out. What am I essentially doing? Well, if I have 5 and 2 cancel out, I'm left with how many? I'm left with 3. Okay? So just another approach to it. But the general rule, again, is that if you divide, you have the same base, you subtract your exponents. And the last rule, squeeze this in here, is that if you raise something to another power, that means you multiply the exponents. So if it's being raised to another power, so this is 5 times 2, which is 10, and this would be 10. Why does this work? Because what is x to the 5th squared? X to the 5th squared is x to the 5th times x to the 5th. And because I have 2 of these, if I add 5 plus 5, I get 10, but a shortcut to this is 5 times 2. So if I change this to a 3, this would be, I would include another x to the 5th, and it'd be 5 plus 5 plus 5, which is nothing different than 5 times 3. So in any case, the rules are, if you multiply, you have the same base, you add the exponents. If you divide, you subtract. And if you raise something to another power, then you multiply. Okay. Let's use these rules to tackle the next question, or to tackle this question. So I'm giving you, or the question is 3x squared y to the third, and all that's going to be cubed. Now, one thing to stress here is that there's technically this 3 is being raised to the 1, and actually every number has three things associated. You have the 1 in front, and if you have me as a teacher, I tend to refer to this as the phantom 1, okay? Because every number's got a 1 in front. Then you have the 1 on your shoulder that helps you out when telling you what to do or what not to do. And then, of course, there's the 1 that keeps you up when you're falling down. Okay? So every number has 3 ones. You can multiply by 1. So if I give you 3, 3 is the same thing as 1 times 3. It's the same thing as 3 to the 1, and it's the same thing as 3 over 1. All of these are true. So you can always rewrite every number, every integer in this way. Okay? All right, so if I look at this question here now, going back to this question, so this 3 is 3 to the 1, because we are playing with exponents. I'm going to use my exponent rules. So the exponent rule that I'm going to start off with is the third one, which is that if you raise something to another power, you multiply. So I'm raising each of these to the third, so I'm going to multiply each of these exponents by 3. So this becomes 3 to the third, x to the 2 times 3, which is 6, and y to the 3 times 3, which is 9. As such. Okay? Now, be careful. A lot of students see 3 to the third and think 3 times 3. That's wrong. This is 3 to the third, which means 3 times 3 times 3. Right? Which is going to be 9 times 3, which is 27. And there's your answer. Okay, so the correct answer here would be, what is this, x to the 9th, D. Okay, now what's another approach that I could take to this? Alright, another approach to this problem is if I give you variables in the question, alright, I can make up numbers for x, I can make up numbers for y, I can substitute it in and see which ones match up. So I could go through this question, and I'm going to look carefully and see that I don't want to use 2, I don't want to use 3, I don't want to use 5, I don't want to use 6, I don't want to use 9, I don't want to use 27. And I think that's about it. So I can use 4. So I'm going to say x is 4. Alright. And what's y going to be? Well, I can't use 5, I can't use 6, I'm going to say y is 7. Okay? Now, this might get a little messy, but we're going to try to work our way through it. Okay. So, when I go through this, I'm going to say 3 times 4 squared, and then I'm going to go 7 cubed. And all of this is going to be raised to the third. Okay? So if I solve this, you have to follow PEMDAS. So PEMDAS says parentheses first, so I have to play with this first. And I'm going to do 4 squared, which is 16, so I have 3 times 16, times 7 cubed, which is going to be, I'm not sure. So I've been avoiding using a calculator this whole time, but I am going to have to end up using one. So I don't have a calculator around except for my cell phone, so I'm going to use my cell phone here. Alright, so you'll have a Calc4 function calculator, so basically you'll have only these abilities. So we're going to do 7 times 7 times 7, which is 343. I knew that. This is 343, and all of this is raised to the third. Okay, so I'm going to clean up the inside. I'm going to do 3 times 16 times 343, 16464, 16464 cubed. So that means I'm going to have to multiply this by itself 3 times. So times 16464 times 16464. Alright, I'm going to get some nasty looking number. This is roughly 4.462786. When it says e to the 12, e plus 12, that means times 10 to to the 12th. All right. Okay. So this is an approximation. This isn't exactly what it's equal to, but it's close enough. All right. If I go, we're saying that the answer is 27x to the 6, y to the 9. So if I plug in the same values again, 4, 6, 7, 9, this should be giving me roughly the same thing. Okay, so that means I got to do 4 to the 6, which means I got to multiply 4. 6 times 4 times 4, that's 2. That's 3. That's 4. That's 5. That's 6. Okay, so this is going to be 4096. That's 27. Going to do the same thing with 7, only 9 times. All right, here we go. 7 times 7, that's 2. 3, 4, 5, 6, 7, 8, 9. It's going to give me 40353 All right, so I take this, multiply. If I do it right, I'm going to get this huge number. Let's see what happens. Times 4096 times 27. Okay, so again, all I do is type in this value here, and I got this, which basically matches up. All right, now I'd have to go through and do this on every single one until I got to the correct answer. So this is ridiculously, like when you get ridiculously large numbers, because whenever you play with exponents, things grow very quickly. But you do get the right answer. So it's kind of tedious. It's kind of, you're going to get some ugly numbers, but it does work. All right. My advice, though, is know your exponent rules. Okay. Hopefully this worked out well for y'all. Make sure you know your exponent rules. Make sure you realize that anything, where was it? Right here. That any number in the denominator can be rewritten as, that whenever you have the exponent in the denominator, you can rewrite it as the base to the negative. So here, we have 1 over x squared, that can be written as x to the negative 2. That's useful. You might see something like that on the TSI as well. All right, guys. Hopefully that worked out well. Let me know. If I can do something to make it better, let me know. All right, see you in the next video.